Equations are easy. Take x minus 3 equals 1. There's only one value of x equals 4 that fits. Any other x value doesn't fit. This differs from an identity. Firstly, it's represented by equivalent instead of equal sign. This allows multiple values of x to be substituted in, and it always holds true as values on both sides always balance out. However, there are rules to adhere to. Terms are not allowed to be manipulated to the other side. Instead, manipulation can only be restricted to each side of the identity like this. You'll usually be presented with polynomial identities with a whole bunch of unknowns to solve. They look something like these. Each case contains unknowns marked out as shown. These are the opponents that you'll be encountering. However, knowing what it is and the rules involved isn't adequate for you to solve them. There are certain plays you need to master before you can solve them effectively, and without them, you can be easily overwhelmed. The most effective play in the playbook is head and tail. Skip the laborious process of expanding all algebraic terms, but yet reap the benefits. I'll show you. For an identity like this, you're expected to solve for a and b. I'll mark out the opponents here. By observing the left side of the identity, I see that the largest term is 2x cubed. On the right side, the terms that can result in x cubed are ax squared and 1x as identified here. The only logical conclusion is to compare the head on both sides and deduce that a equals 2, since there aren't any other x cubed terms lying around. Now we check out the tail end, the constants. On the left, the only constant is 5. On the right, the terms responsible for constants are 3 times negative 1 plus b. Solving a simple equation like that yields a b value of 8. I call the next most powerful play make 0. There are specific situations that, when used, prove really useful in isolating an unknown to solve. This question here contains 3 opponents, a, b, and c as indicated. Watch me choose to substitute in an x value of negative half. Observe the linear factor 2x plus 1 sandwiched here. When x equals negative half, it takes on a value of 0, and since 0 times anything equals 0, the whole chain of 3 linear factors vanishes, taking along a and b. I now only need to solve for c via this equation. With the help of a calculator, c equals 4. But what about a and b? They haven't disappeared for good. Watch how I employ the head and tail play again over here. The largest term on the left is negative 6x cubed. I can eyeball the right and equate that to the product of ax, 2x, and negative x. That leaves the simple task of solving for a equals positive 3. Repeat again for the tail terms. The constant 12 equals 4 times 1 times b plus c. With our newly solved c value of 4, solving for value of b becomes relatively straightforward. Here's the third play. Your next best option would be to sub in simple integers, numbers like 0, 1, and 2 for example. Here's the situation. 2 unknowns a and b marked out as shown. Try substituting in x equals 0 and watch what happens. The b value vanishes, which means you have now isolated a to solve. This won't take long. The next most simplest value after 0 would be 1. Try substituting that now to solve for b. Hopefully, you can appreciate how separating the unknowns make your task easier. The last play is called expand everything. It's not a great strategy, and you'll see why. With a case of 3 linear factors, I expand the first 2 as shown. Simplify before moving forward. This minimizes the pain. If you're still conscious at this point, notice how all the terms are laid out for comparison. Solve for a. Solve for b. And finally, solve for c. It's obvious now why expand everything is the worst play. It's intensive and slow, and at best should only be used as a counter-checking method. Now that you're equipped with 4 plays, what now? Knowing when to apply which play is an art in itself, as you're often expected to deal with up to 5 unknowns. A great way to start would be with the head and tail play, which often knocks out the largest or smallest term. But if it doesn't work, don't worry. Move on to the make 0 play. Substitute in an x value that gives a linear factor the 0 value, hence eliminating multiple unknowns. Once isolated, it often allows for another unknown to be taken out. Then, try the head and tail play again if necessary to see if the annoying problem can be eliminated. With just two unknowns left, sub in simple integers to solve one at a time. The values you have solved for prior to this helps make the job easier. Now that you are equipped with the place and strategy, you are all set to tackle polynomial identities. Pick your battles selectively to eliminate unknowns one at a time, and you'll realize that it's much easier than you expected.